Hello, dear audiences. As I have promised in the previous programs, I said that to come with the inverse of exponential function, and today I came with logarithmic function. Okay, but before that, this is Wagahta Study Mentor. As usual, if you enjoy with our video, you can like, share to all of the world, and if you if you are interested with our program, subscribe to our channel WSM. Okay, so let me start our today's lesson by defining what logarithm mean. Okay, logarithmic term, logarithmic expression, logarithmic equation, and logarithmic function. We will see one by one as we have seen in the previous uh, sessions. Okay, as we have said so far, we said that exponential term, exponential expression, exponential equation, as well as exponential function. We have to identify those concepts uh, uh, carefully. Okay, now let's start by logarithmic term. For example, log of x base b. This is a logarithmic term, okay, because of the the sign, the symbol, the sign that we have log. Okay, another example, logarithm of 9 base 3. So we do have different properties on logarithm, uh, like exponential function. Okay, having those properties, we can simplify logarithm of 9 base 3 as, because we can write 9 as 3 to the power of 2, then logarithm of 3 to the power of 2 to base 3 is going to be written by 2 becomes the coefficient of logarithm, then logarithm 3 base 3 is 1 by the property of logarithm. It becomes 2 times 1, which is 2. And when we come to logarithmic expression, log of x base b plus log of y base a. This is a logarithmic expression. Here what we are going to do is simplification only. If possible, we are going to simplify the given expression. And the next one is logarithmic equation. Logarithmic equation can be written as logarithm of x base b is equal to c. Now this is an equation because of the equality sign, and it is a logarithmic equation because we do have the symbol log. Have you seen it? Yeah. So here, in this case, as we have tried to mention in the previous examples, in the previous programs as well, in case of equation, we are going to solve the value of x using different properties of logarithm, okay? For example, logarithm of x base 4 is equal to 1 can be rewritten into 4 to the power of 1 is equal to x because they are inverses to each other with exponential function. We are going to change the logarithmic equation into exponential equation. So it becomes x is equal to 4. And the next one is logarithmic function. To say function, we should have to have at least two variables, okay? Two variables. For example, I can say y is equal to logarithm of x base b. Now we do have two variables, y and x, and this b, the base b is a number greater than 1 or in between 0 and 1. Okay, here in case of function, we will discuss about the properties of the graph of logarithmic function, as well as we can identify the domain and range of the logarithmic function. Here, as we have said in the previous programs, logarithmic function is an inverse of exponential function. Hence, the domain of logarithmic function will be positive real number, and the range of logarithmic function will be the set of all real number. Vice versa with the exponential function. Okay. Here we can sketch the graph of logarithmic function by taking x-intercept and y-intercept as we have done in the previous examples. Okay, so for today it will be enough. Okay, if you like our channel, subscribe, like, and share. Goodbye for today. Goodbye.